Hi, in this video, I'll show you how to submit jobs using HTCondor using a Bioinformatics example. So when we're running jobs on a personal laptop, we usually do so by running one sample at a time. Usually we will submit one job for sample 1, wait for the job to complete, and then type another command to run the same job on sample 2, and so on. So usually this takes a long time to complete all the jobs. Using high throughput computing, we can submit multiple jobs at the same time, and we can use HTCondor to manage and run jobs simultaneously. So this graphic is showing how sample 1, 2, 3, all the way to 999 are being submitted at the same time, and the length of the arrows show that each job takes slightly different time to complete. And this is expected because in a real experiment, each sample will be slightly different, and so some jobs will complete faster than other, but overall the time it takes to complete all the jobs will usually be less because everything can run simultaneously. So I won't go too much in detail into all the specifics of HTCondor, but some things to know for this tutorial is that HTCondor needs 2 text files to know what jobs to run. The first one is called an executable file, and the second one is called a submit file. The executable file is a text file, usually in the form of a bash script, a .sh, but this can also be an R script or a Python script. And these are the commands that are going to be run on this remote machine. The submit file, usually with the file extension .sub or .submit, is also a text file, but that contains the criteria that HTCondor will use to find a spot to run your jobs. So for example, it can contain the link to the software that you want to use, the CPU requirements, the disk space requirement, the memory requirement, and a queue statement listing how many times you want to run the script. With that in mind and that ready, you can use HTCondor to type the command condor_submit followed by the submit file name to submit all of your jobs. So in this tutorial, I'm going to show you 3 examples to demonstrate some of the capabilities of HTCondor for a bioinformatics job. The first example is learning how to submit a simple job. So this will show how you can submit multiple jobs at the same time, and also show you how to use the queue statement and the condor watch queue command to keep track of your job. In this example, you'll also learn how to recognize some of the variables, such as the process variable or the cluster variable, to better understand how your jobs are running. The second scenario will be a little bit more relevant to a bioinformatics task, and that will be to submit a genome assembly for one symbol. So in the second example, we'll be introduced to the concept of container images and how to use them to pull from a container repository. This script will also be a little bit more complex because it will include some pre-job completion steps that needs to be performed. For example, how to zip an output folder so that all the files are exported correctly when the job is completed. Once we've learned how to submit a bioinformatics job on one sample, we will learn how to generalize that script in order to run that same script on multiple samples. And in this one, we will be introduced to the concept of variables and how to use them in the arguments line of the submit file. If you want to follow along, you can go to this GitHub link, and I'll also put it in the video description. So this GitHub link will link you to this GitHub page, and this contains all of the scripts necessary, as well as the instructions. This repository contents here is pretty much what I just explained from the slides. So let's get started. In order to follow along this tutorial, you will first need an access to a CHTC account, and to request an account, you can follow this link. So you can complete the instructions here. And then you will also need to know how to log in to CHTC high throughput computing cluster using the terminal. So the first step is to log into the terminal and cloning or downloading a copy of all the scripts in this repository. So you can do that by typing git clone followed by the web link, and then you will change directory into that folder, and for good measure, you can print a working directory and list the folder contents. In this example, I'll show you how to submit a batch script using HTCondor. So I've already made a copy of the GitHub directory, and this is the folder name. I'm going to type ls so you can see the contents of the folder. So for the first scenario, we're going to be using simple_batch. And you can see here that there are 2 files with that name. One of them has the file extension .sh, and that's the executable file, and the other one has the file extension .sub, and this is the submit file. So first of all, let's take a look at the sh script. The sh script is a bash script, so it begins with the bash header, and inside of the bash script there are two commands. The first one is sleep 20, which means wait 20 seconds, and the second command is echo, which is a sprint statement, and what it does is that it's going to print to the screen current process ID is number 1. Now, number 1 is a variable that is inherited from the submit file. So let's take a look at the submit file. So the submit file is a file that tells HTCondor what types of requirement we need to run our job and what script do we actually want to run and how many times we want to run it. So first it has an executable line, and this points to the sh script. Next, it has the arguments line, which tells it which variables from this file needs to be inherited by the sh script. So in this case, it needs to know what the process argument is. So when HTCondor submits a batch of job, they're automatically assigned a cluster number and a process number. So in this case, we would like to keep track of the process number and print that to the screen inside of each individual job. Next, there's a section with log, output, and error, and these are 3 files that get automatically created. The log file usually contains information about what time your job was submitted, when it started running, when it finished, and information about how many resources you requested versus your job actually used. And it also has information on what computer or what slot your job ended up running on. The output file is the standard output that gets printed to the screen on this remote machine that your job is running on. And the error file is the standard error that gets printed as your job is running. So the next section is request CPUs, request memory, and request disk. And this will vary depending on the job or the task that you're trying to do. So in our case, our executable script only waits a couple of seconds and prints something to the screen. So it's not something that requires a lot of memory or requires a lot of disk. But if you were to do this on a real data set, something for your research, you probably will need to increase these numbers. And the last line of the submit file is a queue statement that tells HTCondor how many times you want to run your job. So in this case, we're going to submit a batch of 100 jobs, but if you wanted to run this even more times, for example 500 times, the only thing that we would need to do is to change this queue statement to say 500 and submit that. So let's submit our script by typing condor_submit with a space and then the name of the submit file. So it says 100 jobs submitted to cluster 5074330. So this is the cluster ID that this batch has been assigned to. To keep track of the status of our job, we can type condor_watch_queue. And this will refresh every couple of seconds to show the status of our job. So this is the batch that we just submitted. All of them are currently running, and it moves pretty quickly from running to output to done. So actually all of our 100 jobs have been completed. And to exit out of this screen, you can type Q, or you can actually press any key. So I'm going to clear my screen so that we're more at the top of this terminal here, and I'm going to type ls. So we can see that there's no outputs in the main output, like in the main working directory. But if we go to the logs folder and type ls, we can see that there are really many files that have been created. And this is because we had 100 jobs running, and for each of those 100 jobs, there are 3 files that have been created: the error file, the log file, and the output file. So let's take a look at any of these output files. So I'm going to look at the process ID number 36. So if I look at the out file, the only thing that is in it says current process ID is 36, and 36 was that variable process ID that we asked the SH script to know about. I'm also going to print the error file, and because there was no error message, this file is empty. And now I'm going to print the log file. So this is what a log file looks like. It usually has a couple of lines that you can always look for. The first one will have job submitted from host, pointing to where you ran your Condor submit, from what machine you ran your Condor submit command from, and the time that you did that. And then once it finds a machine to run your individual job, it will say at what time it started transferring the input files. And then it will say finish transferring the input files. In our case, we did not have any input files, so this is the timestamp here is the same. Depending on the size of your job, you might have one or more of these lines that say job executing on host. And the size of the job, you will only have like one line that says job executing on host with the timestamp, but this line here that says image size of job updated might happen more than once if your job is like really large. Okay, and then we can see here it started transferring the output files at 9:59:26 seconds. And interestingly, you can notice that if we think about what our job was supposed to do, it was just supposed to wait 20 seconds, and after 20 seconds it prints something to the screen and then it ends the job. So it started at 9:59:06, and then after 20 seconds, 9:59:26, it finished. So this is something that we would expect based on what we know about the script. And then finally, after it finished transferring the output files, it will say job terminated. And if the job has completed without any issues, it ran all of the lines of your executable script, then it will say normal termination, return value 0. Now, another section to look for is this section over here, and there's a column for requested and usage. So the first time that you write your submit file, you will estimate how many resources you want to use in terms of disk space, CPUs, and memory. But after you have tested your code, you can actually look at the log file and see how much did each individual job ended up using. And you can optimize your submit file to request values that are more appropriate for your job. And sometimes that can really help because you will have to wait less time for your job to start up, because it will be easier to find a machine with those requirements. So just to show you that these files are a little bit different across all of the 100 jobs, let's take a look at another process ID. So I'm going to use cat to print the contents of the output file here. And we can see here that the process ID has changed. And if we want to look at this for all of the samples, what we can do is we can use the grep command to search for this file pattern inside all of the output files. And we can see here that all of the output files look a little bit different, and indeed the process ID variable is different for all of them. Something else that I want to show you is if we look at one of the log files here, we can also see on what computer each of our 100 jobs ended up running on. So this line here, slot name, will tell us this information. So we will also do a grep command on slot name of all the log files. And what we can see here is that each of our 100 jobs ran on different machines from the CHTC pool of computers. So these are all different machines in different slots on those machines. All right, so this is all that I wanted to show you for the example of how to submit a job. Stay tuned for the next example, which is going to be how to submit a genome assembly using HTCondor. And that video will introduce you to the use of containers and the use of transferring relevant input files and output files.